In this video, we're going to derive the derivative of a to the power of x. So pretty much the derivative of a to the power of x. Now we know that a to the power of x is pretty much just means any exponential function. But even though we may not know the derivative of every possible exponential function, we do know the derivative of one exponential function in particular. Namely, we know the derivative of e to the x. And we know that this is just equal to e to the power of x. And so maybe we could use this idea to help us figure out the derivative of a to the power of x. And so what we would need to do is we would need to convert our base of a into a base of e. And so it turns out what we could actually do is we could say that a to the power of x is equal to this. And so pretty much notice what we have here. Pretty much we've converted our base of a into a base of e. And also, both sides of the equation are equal to each other, because if you notice right here inside the parentheses, this is really just equal to a, because notice how e and natural log would just cancel out, and so we're left with just a. And so yeah, that's the whole idea. And so yeah, we could say this. And also the next thing, right? So the next part is that notice how pretty much this is like the idea of multiplying exponents. And we remember from the rule for multiplying exponents, the idea is that if you have something like this, then this would equal that. So this is basically the rule for multiplying exponents, and we can apply it to right there. So the whole idea is pretty much you could write this as this, right? And so this would just be that. All right, so now that we have this, we can actually find the derivative of a to the x now, because we actually know how to find the derivative of this. So that's what we're going to do. Okay, so pretty much we're trying to find the derivative of a to the x. So all we really have to do is we have to evaluate what this is, and that's all. And pretty much what we're doing here is we're pretty much evaluating the derivative of e to the power of some constant times x. And we know that's just like evaluating something like this. Like if we were to take the derivative of e to the power of 2x. And we know that this would just be the same thing as pretty much e to the power of 2x times 2, because we're pretty much just using the chain rule. And so we apply the same idea to what we're doing here, because it works the same way. And so pretty much what we would get is this, which would be e to the power of the ln a times x. And this is, of course, multiplied by the derivative of this inside function times the natural log of a. And so yeah, because we were using the chain rule. And so yeah, this is pretty much what we would get when we take the derivative of that. Also notice another thing. We know that this right here is the same thing as a to the power of x, because we have that right here, right? This is equal to a to the power of x. So we can just substitute it for a to the power of x. So that means what we have there, we have a to the power of x times the natural log of a. So there it is. This right here would be the derivative of a to the x. And so this would be our final answer. That's it. That would be the derivative of a to the x.